All right, good afternoon. It's 12 o'clock on Wednesday. That means it's time for the Iowa Learning Farms webinar. I'm Matt Homers with Iowa State University and ISU Extension and Outreach. Also work with Iowa Learning Farms. Iowa Learning Farms is a partnership of the Iowa Department of Agriculture and Land Stewardship, the Iowa DNR, Iowa NRCS, and ISU Extension and Outreach. We have many other partners as well, but those would be kind of the four primary ones. Really fortunate to get to host a webinar today, and we get to hear about manure and nitrogen management, certainly a really important topic. And we have with us today Sailesh Sigdel. Sailesh is a PhD candidate in agricultural and environmental plant science at Penn State University. Sailesh works on, among other things, is involved with the grass to gas project, sea change project that have jointly between Iowa State University and Penn State University. So have gotten to interact with Sailesh just a little bit and hear some of his presentations. So really excited for him to share with us today his work on improving manure and nitrogen management in no-till dairy cropping systems. So Sailesh, the virtual floor is all yours. As always, if folks have questions or comments or questions specifically, please type those in the chat box and we'll get those to Sailesh at the end of the talk. And with that, the virtual floor is all yours.
Thank you, Matt. Hello, everyone. First of all, I'd like to thank Iowa Learning Farm for inviting me uh, for this webinar, and I want to thank all of you for tuning in today. Just to briefly introduce myself, I am Sailesh. I am a PhD candidate at actually, I defended last month in Agricultural and Environmental Plant Science program from Penn State. And today I'll be sharing.
Sailesh, I'm sorry, I should have introduced you that way, that you had defended. So congratulations.
Thank you. Thank you,
yeah,
Matt.
yeah.
No worries. Okay. So today I'll be sharing some of my work that revolves around improving manure and nitrogen management and no-till daily cropping system. Specifically, I'll be talking about two case studies from Pennsylvania where we looked at anaerobic digestate and raw manure, right? So let's get started. So if we talk about Pennsylvania, or like when we talk about Pennsylvania, animal agriculture is the major commodity, right? So this means this region accounts for a huge number of farm animals and cropland dedicated for it. And with the time, such farms are consolidating, getting bigger and bigger. Now they have like high animal stocking rate. They are more specialized. They have like high and now they have to like import feed and fertilizer, for example, from Midwest to meet their production demand, right? And with such change in such farms, they have to import like feed and fertilizer, and with along with that feed and fertilizer, they are also importing nutrients, right? So the nutrient that they import in such feed and fertilizer is often greater than what Pennsylvania exports or what this region, like the Northeast region whole exports, right? So this has created a regional nutrient imbalance in this part of the United States, which has led to like a nutrient and sediment pollution. And one of the common example of this problem is nutrient pollution to Chesapeake Bay, which comes in for like nitrogen, phosphorus, and sediment load that reaches to this part of the United States. And this is not a localized problem, not only to like Northeast United States. There are like more than like 400 such hypoxic zones around the world, right? And the most relatable for the Iowan folks or for the Corn Belt folks is nutrient pollution to Gulf of Mexico that originates from the Mississippi River Basin, right? So the nutrient water runoff, along with like nitrogen, phosphorus, and sediment, like runs into the Gulf of Mexico, leading to a dead zone or like a hypoxic zone, similar to the Chesapeake Bay watershed. So animal agriculture is not only associated with, let me type this video panel. Animal agriculture is not only associated with the nutrient pollution to the water bodies. Dairy farms are also a major contributor to the global warming, as they are a major contributor of like two specific greenhouse gases such as methane and nitrous oxide. And when we talk about this methane, this is 25 times more potent than CO2, right? And with the time, there have been advancement in technology that led to installation of anaerobic digesters in commercial dairy farms in Pennsylvania. Such farms capture this process captures like the methane and produces biogas, which is often utilized within the farm to generate electricity or heat their farm or export it to the national grid, right? And besides the production of renewable natural gas during this anaerobic digestion process, this process also leaves out a huge amount of byproduct, commonly known as manure digestate. And if we talk about this manure digestate, at least in Pennsylvania, it is very common in such dairy farms to separate solid and liquid fraction out of that digestate manure. And the solid fraction here is dried and used as bedding for cows, whereas this liquid separated digestate is used as a fertilizer, right? And when we talk about this liquid separated manure digestate, it is high in ammonium and high in pH compared to raw manure. So it is a different source, right? So, and a business as usual practice or a typical practice in such farms is to surface apply the digestate manure, right? And what we know from the previous research with the raw manure is that the surface application is linked with the high volatilization loss, right? And which reduces like manure nitrogen availability, its fertilizer value, and it also contributes to many environmental problems. And if we relate this back to a digestate, which is high in ammonium and high in pH, there's even higher potential for loss through ammonia volatilization. And this loss of ammonia is really critical because not only this ammonia is the major nitrogen loss pathway, it is also considered to be a water and air quality pollutant, right? On top, it is also associated with different human health impact from production of like particulate matter. It has been linked with many cardiovascular and respiratory issues in human beings. And on top, it leads to a surface water eutrophication and groundwater contamination. So it is critical to control the loss of nitrogen in the form of ammonia after such manure digestate application. And one thing we already know that manure injection is a proven practice that place manure just below the soil surface with like minimum soil disturbance. It is a big thing in this part of the Northeast United States. No-till is a big thing. So and the prior research also has shown that this immediate incorporation helps to conserve manure nitrogen for crop production, right? And it also, if phosphorus is an issue in your farm, manure injection also helps to reduce that phosphorus runoff loss, right? So realizing this importance of like immediate incorporation, we hypothesize that liquid digestate injection will reduce ammonia gaseous loss as well as increase corn nitrogen availability and yield. And to test our hypotheses, we did a on-farm study across 6 site-tier locations in Pennsylvania. All of our 6 site-tiers were located at commercial dairy farms with anaerobic digesters, right? Where we compared liquid digestate injection to surface broadcast, which is their like prevailing or business as usual practice. And at each site-tier location, we established side-by-side field scale treatment comparison strip, which were replicated 5 to 6 times. And to compare our treatments, inject versus surface broadcast, we looked at ammonia loss in first 24 hours after that liquid digestate manure was applied. We looked at if the corn planted needs additional side dress nitrogen. And at the end, right before harvest, we looked at the nitrogen status of the corn plant throughout the growing period. And at the end, we also looked at the corn silage yield. So when we characterize the farms with anaerobic digesters in this study, all of them are like long-term no-till, at least with like 20 years of no-till history. They double crop winter cereal rye or tritically with corn silage. They apply digestate at a high rate ranging between like 5,500 to 10,000 gallons per acre. And they do this manure digestate application 2 to 3 times a year, like typically after spring green up in March, before corn planting in May, and after the corn silage harvest, or before the winter annual planting in September, right? And on top, they're adding inorganic nitrogen in the form of starter and side dress nitrogen. So if you look at this, it is a very nutrient heavy system, right? So, and when we looked at their like initial soil test, it shows a typical representation of a farm that has a long-term no-till history and high level of high level of phosphorus in top layer of the soil, right? For Pennsylvania, the optimum phosphorus level ranged between like 30 to 50 ppm. So if you look at these numbers, that are like way above like what's considered optimum for the crop growth, right? And when we characterize the liquid separated manure digestate in this study, if we just compared it to raw manure over here, you can see liquid digestate and raw manure, it has low solids compared to a typical raw manure. And if you look at this ammonium to total nitrogen proportion, if you just look at the liquid digestate across all the farms, uh, on out of that total nitrogen applied, 45 to 79% of what's being applied was just ammonium. And if you don't know about this ammonium, it is the form of nitrogen that's readily available for plant uptake, right? So on average, across the farm, like 60% of what was being applied was like readily available to plants. If you compare that to raw manure, it has like only 38%, meaning more of what's being applied is organic nitrogen, which is not like immediately available uh, for the growing crop, right? And we also noticed that digestate differed across the farm, depending on farm specific digester management process and input that goes into that digester, right? For example, the farm that like co-digest like food waste, byproduct, and waste material along with the raw manure, they have like higher nutrient composition compared to the farm that just uses raw manure as an input or as a feedstock for that digestion process. So the first thing after the manure digestate application, we measured ammonia loss, right? For that, we used a semi-open trap or chamber, as you can see in this figure on the right. We established such 2 to 3 acid trap per treatment plot, and we captured the ammonia for 24 hours after manure digestate application. And moving towards the results, this is the ammonia loss at one of our farm in 2021 growing season. On x-axis, we have time after manure digestate application. On y-axis, we have ammonia loss rate. Here, the black circle represents the rate of loss for the surface applied manure digestate, whereas the red inverted triangles represents the rate of loss for injected liquid digestate, right? Manure digestate. And you can see at 1 hour and 6 hours after that liquid digestate application, there was a significant difference in rate of loss for the broadcast and inject, right? And when we looked at, and we saw a similar trend across all of our 6 ITL locations. And when we looked at across 6 ITL location, we saw that ammonia loss rate was almost double for surface broadcast compared to inject. So meaning, like if you surface apply a liquid digestate, you're losing nitrogen at a double rate compared to when you inject. And when we pooled our total ammonia loss during that first 24-hour period after that liquid digestate application, we saw that injection significantly reduced ammonia loss by 58% compared to their prevailing or like business as usual practice of surface applying. And at each of these farm, the rate of application were different. The temperature when the manure digestate was applied, it was different. The ammonium concentration in the digestate being applied was different. So, and all of these factors can affect the ammonia loss, right? So we wanted to see what was the most important factor that favors the ammonia loss. And when we looked at all of those factors, our analysis showed that it does matter whether you inject or surface applies, as as you can see, the manure management was ranked as the most important predictor of that ammonia loss, followed by soil temperature and solid percent. So for the soil temperature, as the temperature go up, you will see higher ammonia loss compared to applying in colder temperature. And after that digestate application, the farmer came in, they planted the corn, and we went back when the corn was about like V5, V6 stage, or 30 centimeter tall, or knee-high stage, right? And we collected the pre-sidedress nitrogen test to quantify if the corn need additional sidedress nitrogen. I think you guys have a similar test you call it like late spring nitrogen test to quantify any sidedress nitrogen need, right? So we collected the soil samples from both of our treatments, inject and broadcast, from all of our 6 site yield location, right? If you look at the results, you can see the PSNT test said like 5 out of 6 farm, there was sufficient nitrogen available for the corn, right? Meaning no need to add additional sidedress. But out of that 6 farm, 2 farms still added extra sidedress nitrogen when it was not needed at all. And this is one of the challenges that we encountered during our on-farm study. It is, and this, our study is on-farm conducted at like a commercial dairy farm. It's a big operation. So it is always hard for us to convince them like not to sidedress because it is one of their like major supply for the production or the dairy production operation, right? So after that, right before harvest, we also did a corn stalk nitrate test. Just to give you an idea, this test gives an idea whether the corn had like sufficient nitrogen, too much or too little throughout the growing period, right? So for that, we collected 8-inch section of the corn, 6-inch above the ground, right? And we looked at the corn stalk nitrate level in such 8-inch section of the corn stalk, right? And here we can see our results for the 6 site yield location, and the optimum CSNT level is between like 700 to 2,000. And if you look at the numbers across 6 site yield location, the CSNT was 2 to 3 times more than what's considered like optimal, right? And if when we pulled our data across of our 6 site yield location, we saw that corn stalk nitrogen level was like 45% greater in the injected treatment compared to surface broadcast. And we attribute this to more nitrogen being conserved in the injection treatment, as we saw that there was like 58% reduction in ammonia loss with this injection of that manure digestate compared to this surface application, right? So these are some pictures from our harvest of, as I mentioned, this is a commercial farm. So you can see this is how we harvested our corn silage. And going back, both of our CSNT and PSNT said there was like more than sufficient nitrogen available for the corn, right? Meaning we didn't expect to see a treatment difference, as nitrogen was not limiting factor in both of our CSNT in our corn for both inject and broadcast treatment. Yet when we looked at the corn silage yield, 5 out of 6 farm, we saw higher yield trend with the injection treatment, except for the one farm, right? And when we pulled our data across our 6 site yield location, meaning more confidence in our data, more sample size, we saw that injection significantly increase the corn silage yield compared to the prevailing practice of surface applying that liquid digestate. Yes, yields are very important. What's more important for the farmers is it should make sense, right? So we translated that yield gain in terms of dollars per acre. For that, we did a partial budget economic analysis. Here we have a example of partial budget economic analysis for one of our farm in 2021 growing season. When we account for the corn silage yield for injection and broadcast corn, and when you account for the corn silage value, which is like $50 per ton, cost of production, which includes extra $25 per acre for injection, the difference in net return from broadcast for this specific site yield location was $20. And 5 out of 6 farms where we saw yield benefit, the injection increased net return compared to surface broadcast. And the difference in net return across our site location was it ranged between like $15 to $37 per acre, right? And one farm where we did not see yield difference, injection did not increase net return compared to surface broadcast. So what we learned from this case study, we saw that digestate is very rich in ammonia, also high in pH, which makes is prone to volatilization. I just want to remind you that ammonia volatilization is the major nitrogen loss pathway, right? And we also saw that injection actually helps to reduce that ammonia loss by 58%, which is really uh, by 58% in a significant numbers, right? And we also figured out, we also observed that factors like high soil temperature, high solid, and elevated pH increase the volatilization risk. So these things should be considered when applying such digestate, liquid separated digestate manure out in the field. And so our soil fertility test, early season soil and cornstalk nitrate level at harvest indicated there was more than sufficient nutrient in the soil. So we have seen that this is mainly due to the long-term digestated manure application that led up to the high soil organic matter and P phosphorus buildup. So we noticed there was some soil fertility concern at such commercial dairy farms at the such high nutrient buildup can increase the risk of nitrogen and phosphorus losses, right? Though both of our CSNT and PSNT said there was like more than sufficient nitrogen available for the corn, we believe that corn in the injection treatment might have had like early advantage in the season, as we saw that injection increase yield by 4%, which also translated into higher net return and ranged between like $15 to $37 per acre, right? By having said that, looking at this fertility concern at such commercial dairy farms, we still need to evaluate like reducing or eliminating site-rest nitrogen to further reduce or minimize the nitrogen losses originating from such big operations, right? So as we moving forward, nitrogen management in agricultural setting, it always comes with like many challenges, right? Because nitrogen, it has many forms, and depending on forms, it has many fates, right? As you can see, the nitrogen has many loss pathways, which is represented by red arrow in this illustration. So any nitrogen source, if it's not immediately incorporated or not taken up by the crop or utilized by microbe, it can volatilize as ammonia, it can run off, it can leach, or it can be lost as nitrous oxide through nitrification and denitrification, right? And we just saw from our on-farm study that ammonia loss can be quite high from surface applied manure, which reduces its manure nitrogen availability, its fertilizer value, and it also contributes to many environmental problems, right? And we also saw that manure injection helps to significantly reduce that ammonia loss. But there have been many research now which shows that manure injection leaves more nitrogen in the soil susceptible to emission as nitrous oxide through 2 different processes, nitrification and denitrification. Even though this nitrous oxide being lost is really small proportion compared to this ammonia volatilization loss, it is still concerning because this nitrous oxide is another potent greenhouse gas, which is like 273 times more potent than carbon dioxide, right? So it is critical to control the loss of like manure nitrogen in the form of nitrous oxide after that manure application. And one thing we already know with the manure injection is that the manure nitrogen is being delivered at the right place, right? But there was still a question that needs to be answered, that if we could further reduce that nitrogen loss in the form of like nitrous oxide by timing it more efficiently, right? And to answer this question, we did another study where we looked at different application method and timing along with cover crop to reduce ammonia and nitrous oxide gas. And we also wanted to answer whether this practice would sustain the corn yield, right? And to answer this question, we compared two different application timing. Early in the spring on a growing cover crop versus like later in the spring after cover crop termination. So the late spring manure application after cover crop termination or before corn planting is a business as usual or prevailing practice in this part of the Northeast, whereas this early spring manure application on a growing cover crop is more aspirational or a better management practice that we want to test. And these two application timing were evaluated under two different methods of application of manure injection and the prevailing practice of surface broadcast, right? And we hypothesized that early spring manure application for both inject and broadcast to a growing cover crop will facilitate cover crop manure and uptake, reduce ammonia loss, and reduce nitrous oxide emission, and also sustain the corn yield, right? And as a part of experimental design for this study is with raw manure, not with the digestate. And the study was designed as a randomized split block design with 4 blocks, where the whole plot compared two different manure application method, inject versus surface broadcast. And within that whole plot, the subplot factor compared the application timing, early spring manure application on a growing cover crop versus late spring application after the cover crops are terminated. And in this study, the manure was injected at every 18-inch band. And there were like 4 treatment combination, as you can see over here. The study was conducted at Rock Spring, Pennsylvania, and the study was coupled within the Penn State Dairy Cropping Systems experiment, and the study was repeated over 2021 and 2022 growing season. And the corn in this study was grown after the interseeded annual ryegrass and red clover that receives manure in the spring. The manure was applied at 4,300 gallons per acre. And so the manure, if you compare this to a commercial dairy farm cropping system, it is a bit different. As you notice that the soil organic matter at commercial dairy farms are way high, but if you look at this dairy cropping system site, the organic matter is pretty low. The rate of application was also low. The bigger difference is that if you just compare to raw manure and digestate, the raw manure has like the ammonia proportion is smaller compared to the digestate, right? And the manure frequency at this site or this crop rotation is like 4 times out of like last 6 years. If you compare that to a commercial dairy farm, they have been applying 2 to 3 times a year. So that's another huge difference between this study and the other study, right? So in this study, the manure was applied at 4,300 gallons per acre, and across 2 years, the total N applied with this manure application rate was 150 kilograms of nitrogen per hectare. And as with any manure study, the first thing we measured was ammonia loss. In this study, we captured ammonia for 72 hours after manure application, and we used the same method. And moving towards the results, here is the results for 2022 growing season, where we have ammonia loss rate that compares early spring manure application to a growing cover crop versus late spring manure application after the cover crops are terminated or before corn planting, right? And here on x-axis, we have rate of loss. We have like a time after manure application. On x-axis, we have rate of loss. Here, the solid line represents the rate of loss for surface applied broadcasted manure, which as the dotted line represents the rate of loss for injected manure, right? And you can see at 1 hour and 6 hours after manure application, there was like significant difference in rate of loss, right? As we saw in our on-farm study, 1 hour and 6 hours after application of like manure digestate, it is really important. And you're losing nitrogen at very high rate when you surface apply compared to inject at these time point. And if you just compare this early spring and late spring, you can see the magnitude of loss was really high for late spring manure application. And this is mainly due to the absence of cover crop and the high temperature compared to early spring manure application. As you can see, the temperature were like pretty cooler early spring compared to a late spring application. And we saw a similar trend in our 2021 study as well. And when we pooled our data, like we looked at the cumulative ammonia loss for that first 72 hours after that manure application, we saw that the late spring broadcast manure after the cover crop termination had the greatest ammonia loss over both years. As you can see, it has significantly greater ammonia loss compared to all other treatments. One interesting thing is, like you can see here, there was no difference in inject early versus inject late, which means that that immediate incorporation is already doing its job, right? The injection is working. And after that, we also looked at biomass and uptake, manure and uptake in the cover crop biomass. We saw that there was a significant effect of application timing, as we saw that biomass nitrogen was 86% greater in the cover crop that received manure early in the spring versus cover crop compared to like the treatment that received manure in the late spring, right? And one of the questions we often get from the farmers or anyone tuning into this study is like, well, the manure nitrogen is being tied up in the cover crop biomass, right? But when we look at the C2N ratio of the cover crop, we saw that C2N ratio in the early spring treatment was significantly lower compared to the late spring treatment. So this means even though the manure nitrogen is being channeled up into the cover crop biomass, the C2N ratio says like when it's terminated, it's pretty quickly released, supplying nitrogen to the corn, right? So after that biomass measurement, the corn was planted after that manure application, and we measured the nitrous oxide, which is the another pathway of the nitrogen loss, and we measured this nitrous oxide throughout the growing period, right? We established such two chamber treatment plots, and we measured nitrous oxide 2 times a week and also following a day after rainfall event throughout the growing period. And when we looked at this, like changes in daily nitrous oxide flux measured over time after manure application in 2022 growing season, here we have like day of year, as well as you move up, swell temperature, swell moisture, precipitation, and changes in daily nitrous oxide flux throughout the growing period, right? Here, E represents the early spring manure application into a growing cover crop. Here, the L means the late spring manure application after the cover crops are terminated, and P means corn planting. And a couple of interesting things here. You can see the magnitude and peak of nitrous oxide loss varied throughout the growing season, right? We can see increase in nitrous oxide flux after manure application, particularly especially higher nitrous oxide loss after late spring manure application, when there was absence of cover crop, the corn was just planted, the temperature were warming up, and there was some moisture or moisture from the precipitation happening during that period, right? And if you compare this late spring manure application to a early spring application time, you can see there was not much activity going on, right? Because the temperature were cooler and there was actively growing cover crop. And similar trend, as you can see later in the season, when the corn was fully established and taking up any available nitrogen. The nitrous oxide were almost negligible in the later in the season. And when we looked at the cumulative nitrous oxide data throughout the growing period, we can see some interesting things over here. And we tested some of our hypotheses using a slice test, and we were interested to see a couple of things. For example, previous study said that if you inject manure later in the spring, you see a higher nitrous oxide compared to the late spring broadcast, right? Though we did not see a significant difference between this late inject and late broadcast, we saw there was a trend because these were not significantly different at 0.08 p-value. And as in line with our hypotheses, we did not see significant difference when you inject or broadcast early in the spring when the temperature were cooler and there was a presence of actively growing cover crop. But you can see there was like a effect of application timing. As you can see, these late broadcast was significantly greater compared to early broadcast, and late inject was significantly greater compared to inject. And when we pooled that across the application method, we saw that early spring manure application manure were like the nitrous oxide were like 48% less when manure was applied early in the spring to a growing cover crop versus late in the spring after the cover crops are terminated, right? Which is a really interesting result. And when we looked at the pre-citrus nitrogen test or late spring nitrogen test, we saw that there was a greater nitrogen conservation with the injected treatment, meaning you need less nitrogen when you inject manure compared to a surface applying manure, right? So you're saving money. You don't have to buy much when you inject compared to surface application. And this was validated by our late season corn stalk nitrate test, which again showed there was a greater nitrogen conservation with injected treatment. And at the end, when we look at the corn silage yield, we saw a couple of interesting things over here. The injecting manure early in the spring increased corn silage yield by 19% compared to surface application early, right? But the inject treatment like a maintained yield compared to a late inject treatment. As you can see, they were like not significantly different, but the early surface application produced less corn compared to late banding. So this is one thing we that farmer should consider if he's planning to surface apply more early in the spring to a growing cover crop. So what did we learn from this study? Like we saw that in injecting manure into a growing cover crop early in the spring when temperatures are cooler, mineralization is slower, cover crop taking up, and it is a win-win strategy because we saw that it reduced ammonia loss, increased nitrogen availability. It also lowered nitrous oxide emission and also maintained corn yield compared to late spring injection into terminated cover crop, right? And also the surface applied manure into growing cover crop early in the spring. This practice also reduced ammonia loss, increased nitrogen uptake by cover crop. It lowers nitrous oxide. However, the farmer should be aware that it might result in slightly reduced lower yield compared to the late spring broadcast application. So finally, I'd like to thank all of our supporting funding agencies, Sea Change Project, USDA NIFA for funding this research, all of our cooperating farmers and manure haulers who helped during this study that was conducted in Pennsylvania. And if you have any question, I would love to answer those. Thank you so much.
Thank you, Sailesh. That was really interesting and important work. So we will have time for questions here in a second, so type those in. But I think we have a couple logistical slides here to go through, maybe from Elena. First one is probably if you can go ahead one slide. There we go. If you watch this webinar live and are wanting to earn a CCA CEU, please email Elena Whitaker, ALENAW, at iastate.edu by 5 o'clock today. Include your name, the name you entered to watch the webinar, and your CCA number. Again, ALENAW at iastate.edu. We can go to the next slide. If you watch this webinar live and are willing to fill out a voluntary demographic survey, we'd greatly appreciate it. iwilllearningfarms.org/survey, or you can scan that QR code. Let's go ahead one more slide. We'll put a plug in with John Fike, a professor and forage extension specialist at Virginia Tech. Nobody wants trees in pastures, do they? Question mark. So please tune in to hear Professor Fike next week talk about trees in pastures. And I think we might have one more. If you watch this webinar live and want to watch it again or know somebody that might benefit from it, we have them archived on the iwilllearningfarms.org website or you can go to the YouTube page. There's one specifically for the webinars. So please go back and watch or encourage others to watch. All right. We do have some great questions in here. So maybe we first start with the farmers that you worked with. Do they typically test the NP and K content prior to the use?
Uh, that's a great question. I think yes. The straight answer is yes, because it is required by their nutrient management plan to
Okay.
test the nutrient content in the digestator like manure.
Okay. So this one kind of is maybe thinking about it across both of your studies, but um, person asked, do you know if the N loss is greater in the digestate or I guess just the liquid undigested manure?
Well, that's a great question. We have not, to answer a question, we have not specifically compared digestate along alongside with raw manure, but just
Okay.
looking at the nutrient composition of the digestate, it has higher ammonium, higher pH, right? So when you let's say you do a surface application, you will tend to have like more ammonia loss compared to raw manure. Just looking at the nutrient composition or like higher ammonium concentration in the digestate compared to raw manure. Where if you look at the raw manure, it has like lower proportion of ammonium to total N compared to a digestate.
Um, okay, kind of a couple that are kind of related, I think.
Mm-hmm.
Um, this one is kind of why is the nitrous oxide discharge higher in the late injection option? And then somebody asked, did you look at how temperatures impacted the volatilization in N2O emissions?
Uh, that's a very good question because if we let me just pull up to that slide. So, so the basic idea behind the injection is placing the manure just below the soil surface and like closing it, right? There's a like a disc that moves with, as you can see over here, like it's pretty close. So it creates like a band underneath the soil that is more conducive for nitrous oxide emission, which is like you have enough nitrogen, enough soil organic matter or carbon or enough moisture, right? So that creates like an anaerobic situation in the soil that leads to an emission of nitrogen in the form of nitrous oxide. So an injection happens to be like a really good leading to a really conducive environment for the nitrous oxide emission.
Okay.
And yes, the another question to how does temperature affect that ammonia volatilization and nitrous oxide emission? Temperature has a huge role, as you can see that with the increasing temperature, you tend to have a higher ammonia
Okay.
loss, right?
Mhm.
So it is, and also with the nitrous oxide is mainly favored by microbial activity. And
So
when
that'll
you
speed.
have like higher temperature, moisture, the microbes tend to like act more or more rapidly producing nitrous oxide emission. So in both cases, the soil temperature has a huge role and increases, and the nitrogen loss increases with high temperature.
Okay. Okay, there was one here. Okay, oh no, I'm going to ask you my question. So
Okay.
I'm going to take my prerogative as a moderator because you
Mm-hmm.
talked about I think, with that surface applied in the early spring with the manure
Mm-hmm.
that you didn't see um, kind of some increased N losses, at least compared to the other early spring with manure. But what you saw was that the yields for the corn were lower. I'm
Yes.
correcting. So if we think about that as a system and how a producer might utilize that, might they end up applying more nitrogen to make up for any potential reduction they might see in the in the cash crop?
That's a good question, Matt. So one of the thing we noticed is that in to this specific treatment,
Yeah.
we believe this reduction is was mainly due to this cover crop releasing nitrogen too early before the corn
Oh,
could take it up, right?
okay.
As you can see, the nitrogen that was tied up in the cover crop biomass, it has like really low C/N ratio, meaning when it was terminated, it was released like really quick. And though we did not like tested like have a supporting data to see like whether that was the truly case, but the literature and based on our data, it looks like the cover crop terminated released the nitrogen too quickly before the cone could
Okay.
take it up, so leading to a nitrogen limitation in this treatment, which was also shown in as you can see over here, right? As you can see, the nitrogen, the CSNT
Yeah.
test showed that nitrogen was pretty limited in this treatment. So in this case, I would say if you plan to apply manure early in the spring to a growing cover crop, I think injection is only way to go, is the best way to go because it is a win-win strategy compared to
Yeah.
applying applying early spring like as a typical surface application practice.
All right. Okay. Where's this? Any hypothesis on, I know you didn't measure it, but have you guys talked about what some of these result or how might some of these treatments impact nitrate leaching? Um, and whether or not, I guess also whether or not you would expect to see when you've applied these with surface runoff, whether you'd expect to see maybe some increased loss with runoff as well.
That's a really good question. Yes, in this study we did not measure nitrogen because the topography out in the sites where we conducted our study, it is very rocky, so we could not like deep dive into that nitrate leaching part. But that's true. The surface application is associated with the runoff. So if it's not immediately incorporated, uh, you might expect to have runoff if there's like a rainfall event or if the manure application is near to the water body, right?
Yep.
And that's one of the bigger challenges of concern in this northeast region or like Chesapeake Bay watershed, because most of the nitrogen, phosphorus, and sediment pollution that reaches the watershed originates from Pennsylvania agricultural farm surface applying manure. So an injection really helps to
Yep.
reduce that runoff of nitrogen, not runoff of nitrogen. And when you inject, uh, you kind of like incorporate that manure, reducing the chances of leaching or runoff through the rainfall event that might happen after application.
Okay. Um, Maybe kind of the last one in the interest of time, but can you speak on any barriers to adopting injection beyond cost and change of equipment?
Uh, yes. So when we started this on-farm research 2021, we meet like annually with the farmers and share the results and hear their feedback. And one of the concern among the farmers was like time, because they have been uh, they it they think that injection takes a lot of time to cover like per acre basis,
Yeah.
right? Compared to surface application, you just like when go in and apply and come back and do the next run, right? But inject, you have to line up. Uh, for them, I think it is the time is one of the biggest issue because they have to like cover so many acres
Yeah.
uh, within a within that critical time.
Yeah.
Mhm.
Okay. I hadn't thought of that, but yeah, that's
Mhm.
probably exactly true that
Mhm.
it might take more time. All right.
Mhm.
Sailesh, thank you so much for
Mhm.
a great presentation and all your great work on this. And again, congratulations on your positive defense.
Thank you. Thank you.
Excited there. I have to ask, what do you have wires hanging down from your the top of your desk there?
Oh, this is plants.
Oh, okay, a plant. Okay, that's better. All right, all
Right.
right.
Yeah.
I was like, golly, is that yeah? So okay, that's a plant. All right. Hopefully, you're better than me in keeping it alive.
Right.
Uh, okay. If anybody, again, if anybody needs a CCA CEU, please email Elena Whitaker, ALENAW at iastate.edu by 5 o'clock today with your name, the name you entered to watch the webinar, and your CCA number. And again, tune in next week while we're here about trees in pastures. So from Dr. Flick from or Fick from um, Virginia Tech. So with that, thank you all for attending, and thank you, Sailesh, for a great presentation.
Thank you. Thank you, Matt,
Yep.
for hosting me.